So this is page 129. So let's take a look at this. This is a square root. Okay? So square roots basically says, yes, I realize there's a square root key on your calculator, which is great, but sometimes square roots become irrational numbers when they're not perfect squares. So, does anyone know what square root of 16 would be? 4. Okay, so square root of 16 is indeed 4. Okay, well, the reason this works is the math that goes behind it is square root of 16 is 4 times 4. When you're doing square roots, you're looking for the pair. And this happens to have a pair, so square root of 16 comes out nice and easy, being just 4. Does anyone know what the square root of 100 is? 10. And the reason this works is because square root of 100 is the same thing as 10 times 10. And yes, there's other ways you can get to 100. There's other ways you can get to 16. But we're just trying to figure out what number times itself gives me what's underneath the radical. Okay? So then, this is a list of the first few perfect squares. Of course, they didn't put 1, because 1 times 1, then 2 times 2 is 4, 3 times 3 is 9, so on and so forth. So let's take a look at this one, see if I can change that. Can I copy that? Copy. Paste. All right. All right, so basically what you're going to do is, I don't know exactly what number times exactly what number would multiply together to give me 300. So what I'm going to do is I'm going to realize, okay, I'm going to start way down at the bottom of this list. So let's think about this. Is there anything on this list that might work starting from the bottom? So can I go 144 times the number to get 300? Can I go 121 times the number to get 300? Can I go 100 times the number to get 300? Yeah. So is the square root of 300 the same thing as 3 times 100? Does that seem comfortable? Okay, what's the square root of 100? 10. So a 10 comes out, and then what do we have still left behind? 3. So the answer to this becomes 10 square root 3. 10 square root 3 is the equivalent version. It's the reduced version of square root of 300. Good so far? All right. May I move on? All right, so let's do this. We just did that one. Let's go to this one. Okay, I realize you don't have the perfect squares sitting there on your sheet, but I do. All right, first thing I'm going to do. 48 falls about right here. Agree? Okay, so can I go 36 times the number to get 48? 36 times what gives me 48? 36 times what number gives me 48? 36 times what number gets me 48? There's not. Okay. Can I go 25 times the number? Yeah, 25 times 2 is 50, so that's close, but it's not quite there. We can do 16. Okay. So 16 times what? 16 times 3 is indeed the same thing as 48. What is the square root of 16? 4. So I get 4 square root 3. Okay. Now, what I'm doing when I'm looking at this list is I'm approximating where the value would be, and I'm working my way up. If I things to go through. Now, some of you might be sitting there saying, isn't 4 times 12 also 48? And the answer is yes. And 4 indeed is a perfect square, but I was looking for the biggest perfect square that works. That's a square. Is that okay? So it seems a little different than what we're used to, but we're just starting to break down numbers into their... All right, so next one, 12 falls about here. Can I go 9 times the number to get 12? No. Can I go 4 times the number to get 12? 4 times what? 3. So this is the same thing as 4 times 3. The square root of 4 is what? 2. So I get 2 square root 3. Okay, so again, you're just... The one thing that I have not done is I have not gotten a calculator out and I didn't go hit square root of 12 to give me 3 point whatever. Okay, yeah, it's just saying you don't do it that way. Okay, you want to hit this is an exact answer. If you did the square root of 12 on a calculator, that gives you a decimal approximate. What did I do? Oh, you're looking at the next one? All right, 72 falls about here, right? Eyes up on the board, yes? Can I go 64 times a number to get 72? No. Can I go 49 times a number to get 72? No. Can I go 36 times the number to get 72? 36 times 2, right? So this is the biggest perfect square. Okay? So root 72 is the same thing as square root of 36 times 2. What's the square root of 36? What times what gives me 36? 6. So I get 6 square root 2. Everybody good? What? It should be on the notes, aren't they? I mean, there might be some of the same ones on the homework, but not on. Why? Okay. What do you think? I have 3 square root 2 times 2 square root 12. Agree? So one method of going through and doing this is multiply the outsides together. So it gives me 6. And then I have a square root, and then multiply the insides together. 2 times 12 is 24. So all I'm worried about is the 24 right now. So 24 falls somewhere in here. So let's go through our routine. Can I go 16 times a number to get 24? No. Can I go 9 times a number to get me 24? No. Can I go 4 times a number? What's the number? 4 times 6. So I'm going to break this down. The original 6, the outside 6, is going to hang out there. And it's going to come along with 4 times 6 right here. Okay? What is the square root of 4? 2. So a 2 is joining the 6 outside now. And then you can combine. So 6 times 2 this week is 12. So you got 12 square root 6. So again, that is the exact answer. All right. So while you guys are writing this down, exact answers in real world applications, though you might not have this job, but you could, you want exact answers to exist. I don't want to have a decimal approximate, because if you truncate or you cut off part of a decimal, you're going to get an error in there. A lot of times that these exact answers are used, well, in 2025, so just a few years from now, we are actually going to have a space station that we are going to have not orbiting Earth. We're going to have a space station that's going to be orbiting the moon. Okay, I kid you not. This is an international space station. It is not going to be above Earth. It's going to be rotating around the moon. Okay? So will you be on that space station? I don't know. If you are, send me a message saying, dude, I'm up here.
It's like the teachers can go up there, but it's like they can work and teach on the space.
Well, they tried doing that in 1986. They tried doing that back in 1986, and they launched a teacher, and the Challenger exploded about 16 seconds into flight, and everyone was killed on board. So they haven't had a teacher go up since. That's what happens when you get a teacher to the driving control.
Yeah, no.
What you can do? Let's put this, but don't hit that. Whatever you do, don't hit that button. This one, click, boom. So yeah, it was unfortunate. I know. I will tell you. So when that happened in 1986, these are things that did not exist. Cell phones did not exist. Internet did not exist. Well, it existed in the United States military, but it didn't exist anywhere else. Okay, but it. Yeah. Oh yeah, we had the big old 5 1/4-inch floppy disks. And you had to cut the little shape out so you could make your disk two-sided. Your disk would hold 16K memory. Okay?
Also the year before I was born.
So what's your point? 1986?
Oh, 86?
Yeah.
Oh, wait, never mind. I thought you said 80. I thought you said 96 for a second. I was like, what?
I said 86, right?
Yeah.
89? Still, the internet wasn't around then. Well, actually, in 89, University of Minnesota, the Gophers, created the first search engine, which was text-based, which you could like find stuff, and it was called the Gopher because they were the Gophers. And so you would literally on a computer have to do a dial-up modem, get to the internet on a dial-up modem, and then you would have to type in Gopher, open parentheses, what you're looking for, close parentheses, and then type in again, direct find, and you'd hit it. And after about 20 minutes, it would finally eventually come up with something that you're looking for. But yeah, that was back in the good old days. Huh? Oh yeah, there was time. So it was pretty rare to have like an internet in the home. So you go to the library. So what I used to do is I'd hit search on the thing, and I'd go into the library and go and try and find what I was trying to find in books and magazines and newspapers. And then I'd come back to the computer going, oh, look, there is something. I mean, I kid you not. I mean, laptops didn't exist. So when the Challenger exploded in 86, I was in my typing class with Mr. Tracy. Bobby Duenas sat on the left side of me. Heather Hendricks sat on the right side of me. Okay, I'm just telling you. I can tell you the exact people who are in there. And our principal came over to the PA to announce what had happened. And the whole class just started cracking up because we thought it was a joke. And all of a sudden it wasn't. And then so some of the science teachers and history teachers always had a TV with a VCR. So they were able to tune in and watch. So you swing by their room and you take a look at what happened. It was like, oh my gosh. So yeah. Catastrophic days of being a Padre back in the day, because I was Marcus Diniz of Padres. All right, so ready? Let me bring this up. Paste. So again, the space flight things, you want exact values, because if you don't have exact values, there's a margin of error that takes place. And if you need to get exactly to 2√3 miles above a surface in order to have a good orbit, And someone said, no, 2 root 3, let's just do a decimal. Well, if you cut the decimal off a certain thing, you're too low in orbit and you come crashing down the planet. Too high of an orbit, you go flying off in outer space with no way to come back. So exact values do take place. All right, so on this one, I said, which number should I multiply together first? The outside. Does it make sense when I say outside? Okay, so negative 3 times 4 is? Negative 12. And then I multiply insides. What's 12 times 3? 36. All right, so 36 happens to be right here. So 36 is a perfect square. Agree? What's the square root of 36? 6. So then just multiply those together. And that's going to give me negative 72. So negative 72 is the exact number that if I were to multiply 3 square root 12 and 4 square root 3 together, I get that. Oh, so this is the same thing as on this. I just didn't put the little dot there, or I could have went like this. But the problem is if I put the dot there and then you say where'd the decimal come from, if I put the times that looks like an X in there, you say where'd the X come from? So I haven't found the perfect solution yet. Okay. All right. So some of this might look somewhat familiar because basically, as far as math curriculum goes, in 6th or 7th grade, you might have been exposed to something called the Pythagorean theorem. The Pythagorean theorem was come up with by the mathematician Pythagoras in the 6th century before the Common Era, that realized if I have a right triangle and I have a leg and I have a leg and I have a hypotenuse, that there's a relationship. If this is side A and this is side B and this is side C, basically what the Pythagorean theorem means is this. Now, I actually just saw an article that 2 females in the state of Georgia proved the Pythagorean theorem without using ratio trigonometry to do it. And they did it in front of a bunch of mathematicians. So this means a squared. So let me draw what a squared means. This is an a by a square, or a squared. You feel comfortable with that? If this is b, then I'm going to draw a b by b, which is b squared, square. It is equal to the hypotenuse, which is c. So let's make a c by c square, which is c squared, which this is what the Pythagorean theorem means. Do you feel comfortable calling the blue, the red, and the purple squares, kind of? Let's pretend Sturp can draw really well. So the area of this and the area of this added together would give me the area of this. That's what it means. That's the fundamental foundation of the Pythagorean theorem. So if I square something, basically, if you ever square something, you change the dimension of it. Okay? So you guys know 1D, 2D, 3D. Okay? You're like, yeah, we're in the 4th dimension because we have time. Well, time is actually a half dimension because you can't go back in time unless you break all the rules of physics. And I don't know if you know this, but the kinetic equations in physics state that if you were to accelerate a particle of mass, so the smallest little tiny particle that has a mass to it, if you accelerate that to the speed of light, it would take the summation of all of the energy in the universe to push that one particle to go faster than the speed of light. So is it going to happen? Well, according to physics, no. So could there ever be a time machine? So where they get the whole time machine thing is this. So you have a planet. It's sitting in space. This planet, because it has mass, makes the space do this. So if you were to fly around the planet, you have this whole distance here. But what if I could figure out how to go beyond that? This distance here is a lot less. So it's called warping space. So the whole Star Trek thing is actually a true mathematical concept. Okay? So there are thoughts and processes of doing this where you actually create an energy field in front of whatever spaceship you're in that allows you to warp space, so you're bending space-time and you're able to get to one location faster than in a straight line. So it's a kind of a weird, wild thing. Okay, so Pythagorean theorem, if this is a right triangle, aren't you glad that I'm certified to teach science as well?
Yeah.
All right, so this says, here I have a squared plus 8 squared equals 10 squared. Have you all seen the Pythagorean theorem at some point? Okay. I probably went into a little bit more detail than what it actually is. Okay. 8 times 8 is? 10 times 10? All right, so then I have to solve this. Subtract 64 from both sides. Those cancel. A squared equals 36. And then here's where the square root comes in. Square root, square root. So square root of a squared is a perfect square because a times a is a squared. So I get a is equal to square root of 36 is 6. So this would have a distance of 6. Okay? Nope. So this would be a leg. This also would be a leg. And this would be the hypotenuse. The hypotenuse is what the right angle, this means it's 90-degree angle right here, points to.
And also to a good frame is the hypotenuse is always the longest distance.
In rectangular math, yes. You get the spherical math, all the rules change. That's only 7 math classes from here, guys. Basically means you're doing all your drawings of shapes on a ball. Kid you not. Kid you not. It's awesome. And then you get conical. You do all your math drawings on cones. You do all your equations. It's great. I loved it. I actually did because no one else understood it except like some reason this dum-dum got it. Okay. Hey, which of those values up there is the hypotenuse? C? Well, it doesn't have to be C. We can label it every letter we want. You might get some of these where they might call it X. Huh? Always the longest side. Yeah. All right, ready? 2 squared, because that's the leg, plus 6 squared is equal to C squared. 2 squared is 2 times 2, which is? 6 squared is 6 times 6, which is? So I get C squared is equal to 40. In order to undo that, you take the square root of both sides. All right, so let me bring up my perfect squares. Come on over here. All right, ready? 40 is here. So can I go 36 times the number to get 40? Nope. Can I go 25 times the number to get 40? Nope. Can I go 16 times the number to get 40? Nope. Can I go 9 times the number to get 40? Nope. Can I go 4 times the number to get 4 times 10? Okay, so which one's the perfect square, 4 or 10? 4. Square root of 4 is? 2. So I get the answer is C squared, or C is equal to 2 square root 10. So this hypotenuse would be 2 square root 10 in length, which becomes weird when you start having a radical there saying, I thought the hypotenuse was supposed to be the longest side. It is. Yeah, but you have 2 root 10, and I have a leg of 6. Well, 2 root 10 is bigger than 6 because square root of 10 is 3.17173. And 2 times that number gives you bigger than 6. Now you're sitting there checking on a calculator to see if I was BSing you on the square root of 10, which is okay. All right. So, 2 things that we're going to give you. First, I'm going to give you page 131, 132. Hang on, I got to go double check. Hang on, let me take a look. There we go. Okay, so it's all. So 131, 132, 1 through 21, all. And then please note, the SQE purple folder, if you look under SQE number 2, okay, because we skipped the first one, this has the odd answers filled out on Schoology. All right. Now, I need you to do something. Okay, don't go in there yet. I need you to go get your phone. Not yet. Hang on. Does everyone have the assignment written down?
Yes.
Would you hurry up?
I'm trying to. Oh, we're doing the survey.
All right, grab your phone. And we have to change this from stat analysis to CP Algebra 1.
Or if you give a.
And this is period 3.
I think they have to do 3 too. You know. They can do my survey maybe tomorrow.
They could probably do them both. It's only 10 questions.
Yeah.
Y'all get extra credit if you make Stirrup have a higher evaluation than Stone. Just know that.
Thanks. As I'm the one who usually controls the grade book.
You what?
I usually control the grade book.
Yeah, right. Yeah, right. Story time.